Okay, so hello everyone. Thank you for coming. My name is Bardaș Alexandru, and today I'll be presenting you some small updates relating to the ClearFake threat actor. So a little bit about myself. I'm a specialist threat researcher at Gen. I initially started at Avira and then moved on to the Avast Threat Intelligence team. I'm currently mostly interested in malware analysis, Windows internals, and vulnerability research. Also, I'm doing my PhD program here in Bucharest on cybersecurity, and also I'm enthusiastic about mathematics, astrophysics, games, music, so planes, if you want to talk about those, we can as well. So, for today, we'll be talking a little bit about how ClearFake initially started, what was the research telling, what were the payloads that were used, and then we'll discuss some two custom malwares that we've seen being used and some new malware family being adopted by the ClearFake guys behind. And also we'll be discussing the implications of this, because the methods and stuff that ClearFake perpetuated also have some implications on how we see phishing and how the training we do on like beware of this email and that email and so on may not be as useful in this case. So, okay, so about a year ago, a researcher by the name Randy McCoy published some his research on this new malware that he's seen, and which he named ClearFake. In that research, there were a series of JavaScript files which ended up downloading a information stealer at the end. And what was unique about this is that it was using the fake updates lure to trick users into pursuing what the attacker wants them to do. So basically what this lure says, and you have some pictures over there you can look at to see what was actually displayed to the user. It was just a normal page asking the user to update the browser. This lure was used in the past by the likes of Sogulish, fake updates, but this was a new type of payload that was observed using this same type of lure. And this has some implications to the user because, okay, we tell them like beware of specific emails, ensure that you know the sender and so on. But this, like, imagine visiting your favorite website and you just get a notification like, hey, your browser is outdated. I assume some, maybe not you from here, but some others might fall for that, since it's basing on the familiarity with stuff. Like, we get these notifications quite often like, hey, Java is outdated, update me, and so on. So they wouldn't see something odd about being asked to update the browser when they're browsing their favorite page. Okay, so apart from that, those were the initial lures that were used in ClearFake, but mostly those were the big majority of the payloads. But nowadays we see some transition toward what's called ClickFix. ClickFix is another campaign of the ClearFake type, which actually uses goes more into eroding the user's trust, meaning that you can, it bases itself on fixing things like the various Windows errors. Like, imagine you have an error while updating Windows, and you just search how to fix that, and you end up on a page which tells you, hey, run this PowerShell script, and that PowerShell script actually infects you and drops Luma Stealer. And that's kind of bad, because it's not only restricted to Windows errors, you can actually see them for cracks, for game cheats, so even YouTube tutorials or on doing stuff. So it's going far and beyond and trying to trick users with basing their motives on this familiarity stuff. And you can see some examples, some photos there from the actual ClickFix infected pages, and a little bit more over here, like Windows update error, various errors displayed by the web page, custom, and so on. Okay, so also ClearFake was not restricted to spreading via the watering hole attack, which is when they infect websites. It was also spreading by email. It was infecting thousands of known websites, restaurants. Imagine just going at a restaurant, trying to order, and you get a notification saying like, hey, update me. You'll think that's you guys here will think that's odd, but some other users which are not so knowledgeable on this might think that, okay. They even used stolen credentials for the Federal Dispute Resolution Commission in the UK, which was infected like for months. It was actually downloading Redline stealer, so that's nice. Okay, so now we'll just discuss some of the payloads that were seen, how they operated, and we'll dive into the what the web pages look like. So we'll see over here. Let me just get this. So this, oh no. Okay. Okay, so we see here a simple HTML page with a big long title, which is actually a base64 string. And then on the left side, we have the actual code that on this side that decodes that string and then just prints that PowerShell code and just tells the user like, hey, run me to update your browser or fix some error or whatnot. And over here we have the actual PowerShell script that's being run and decoded from that base64. Okay, we have another rendition, another variants of the payloads that they used. So we have just the entire payload in plain text and some logic to copy the command. We have over here, I hope that you're seeing that okay. So we have the double base64 encoding of the payload in a hidden div, okay. Or we can have the entirety of the PowerShell payload in plain text with some base64 encoding, because PowerShell is kind of telling in the functions that it uses, and if you see like invoke expression and invoke web request and so on, you might get some eyebrows raised. Okay, so we start to see how the evolution goes and how they try to make the pages more natural and try to hide themselves. So basically we have on the left side over here, we have a huge list of various translations for the error message to be displayed to the user. And we have on the right side, on the bottom, we have the PowerShell code and the logic to copy it and print it out. Okay. We have another one. We can see very big list. It covers like hundreds of, tens of languages, not hundreds. And we have the code for the PowerShell, the logic for the PowerShell code on the right side. Okay. So most of these PowerShell scripts were just droppers, were stagers in the attack chain. So they didn't do the entire bad stuff, but they rely themselves on that stage, for the end stage payloads, mostly on already known malware, mostly info stealers, as I mentioned here. So we had Luma, Amadei, NetSupport, SteelC, and also from time to time they like to couple them with some of the more advanced loaders, such as hijack loader, IDAT loader, and so on. So I've shown you, I put some pictures over here about that's the runner PowerShell script, so to say, so the end stage PowerShell. That's just dropping the final payload and running it. And for some of you who did their fair share of analyzing info stealers, on the right side over here, generally the .shop domain is associated with Luma stealers. So we have Luma, we have this most likely a zip file, so it's most likely the all the files for NetSupport and so on. And this one is, I think it was Redline. Okay. So now we'll see how they transitioned from the usual, like put the entirety of the PowerShell payload in the page, to trying to add to their stealthiness and making the analysis and the chain even more harder and obfuscated. Okay, so Some time ago, I don't remember exactly where it appeared from. There was this technique called ether hiding, where bad guys actually started hiding malicious code or stuff that they would like to use in Ethereum contracts. And that's what ClearFake began using from, they used those payloads that I've shown before for a few months and then transitioned to using ether hiding. And this is the status quo of the payloads nowadays. They just, they have some base template code in the page that just does some Ethereum calls on the contract via some methods, and from that they get a very small reply, which just moves the chain forward, and they move with the other droppers. And I will show you some examples of what the replies are. So we see on the left side we have the loader for the ethers provider library, and on the right side we have the decoded code and the function call for the contract. Okay, moving further. So as I mentioned, the response from the contract is typically short and just moves the chain further. So we have this on the left side is generally the response after some stages. So we have just an entire HTML page in base64. And then we have the decoder, making it into an iframe. And then lastly, we have the downloader of a zip file. Okay, so we have another example of this. We see the entirety of the script is base64 encoded. Decoding it yields this obfuscated script. This is JS obfuscation 101. Just put it into the obfuscate IO and you get out this script. On the left side, which is just doing the same stuff with the Ethereum contracts. And over here, this is the smaller result that was obtained from the contract. And we just see it's just another eval with another HTML request moving the chain further. Okay, and this is on the left side, this is the response from the other CNC, and if you can believe it, they have the same ether hiding stuff, but in PowerShell now. So it's the same stuff, just this time they are actually decrypting some stuff from over there and end up running it over here with invoke expression. These two are the same script, it's just split into the interesting parts. Okay, so with the increased numbers of information stealers and threat actors that use them nowadays, antivirus companies have actually started improving their detections on this side. So this leaves bad guys looking for ways to thwart the analysis process and see how they can try to trick the antivirus and eventually infect a machine. For ClearFake, we've seen some attempts to create some custom malwares, which we'll discuss going further. And also they move towards using like smaller direction, link shorteners like Cutley, Red.me, and also public code storage websites such as GitHub, GitLab, Bitbucket, and as we've seen in the previous example as well. Okay, so moving on to looking a bit at the custom payloads that we've seen. So we can see over here, I hope it's okay. It's the hex view of a LNK file of a shortcut. And if we comb through it, we can see the PowerShell execution policy bypass, hidden window style, and the command is invoke expression, invoke web request, something from pastebin, which ends up downloading this PowerShell, which is a monstrosity to look at, to be honest. So it goes through, it actually decodes to a huge string concatenation. Is done character by character, so it's a very big file of CHR 100 plus CHR and whatnot, and you end up with this after all of that decoding, which is easily obfuscated PowerShell script, which we can see over here. We can see something, the formatting of paste bin over here as well. And over on this side, we can see Bitbucket. So we can infer that it does it downloads and runs 2 more PowerShell scripts and then runs a PE file, an executable, most likely. And we can see the invoke script from invoke web request, invoke expression. Okay. So the other PowerShell that they were dropping is an AMSI bypass, which is another one of these ugly PowerShell files. This one actually has a different decoding, and I put it over here. It's just IX join instead of the big CHR concatenation using CHR, and another layer of it, and eventually we end up with this script, which I'm not entirely sure if you can see, but it disables user access control over here on this lower side, and on this side we can see the set MP preference and disable real-time monitoring. That's for Windows Defender. And also submit sample consent, disable script scanning, and so on. And over on this side we have the AMSI bypass, which is just a and also some comments from the creator. They are all throughout the file, but sometimes they are funny, sometimes they are just trying to be funny. Okay, and this just replaces some bytes at the beginning of the AMSI scan buffer function, which will end up returning some error. I think there were easier ways to do the AMSI bypass just with a single byte replacement, modifying a jump 0 to a jump not 0 instruction, but they wanted to do it that way. Okay. And the end stage, we can see this is the PE that's running. This is just displayed to the user, and that's that. The window will stay over there, will remain hung, and the user will eventually figure that something's wrong and think that maybe the updater is broken or something. But in background, the PE file is a big Go executable, which acts as a backdoor. Okay, so for the second custom payload we've observed, we have a diagram over here with the entire chain of attack. So we have the infected web page, which prompts the user to download the zip file, which again the victim extracts and runs. The attack starts again from an LNK file, executes an HTA hypertext application file, which leads to a PowerShell dropper, which drops a bat file from GitHub, which then runs a PowerShell, which decodes itself into a PE file, which that PE file, again, we'll see it downloads and decodes and executes some shellcode from some other PE file from Bitbucket, and that will be injected in the process and be the end stage malware. Okay, so this is this was the PowerShell script extracted from the LNK file. It ends up, as I mentioned here, it ends up running MS HTA with that link, and the HTA file from for who's done malware analysis. This is this is not supposed to be a hex file, binary file. It's supposed to be a text file and to be able to be read. But we see over here at the beginning of the file, we see the MZ header, which is typically for PE files. So this is the case of the MNHTAL loader, which basically just has PE files, some regular PE files, typically some small COM applications, where the HTA code is actually injected. So the HTA parser, when you run MS HTA, just scraps everything and just looks for that HTA beginning, and then just looks for known HTML tags that it can execute. And on the right over here, we can see the actual decoded script, which is just some values used in a big concatenation from string from char code. Okay, and then we have just an eval and Windows close, and that's that. For this stage, moving on to the to the other stage, this will end up running PowerShell, which will end up downloading some bat file from some batch file, and we see over here this was again a big batch file. It was like a few megabytes, which was full of this, and then at the end, like parts of the strings required, we can typically see some PowerShell stuff in there being split, and at the end is just run over here by concatenation in batch. And also we can see at the lower side over here, we can see some base64 code, and that's the beginning base64 for some type of archive. So we can imagine that this file will read from it, will run the PowerShell script, which will read the base64 from this file, decode it, unzip the archive, and then run the other payload, which the other payload is a PE file inside, which is a donut loader, shellcode loader from .NET. We can see over here a part of the debugging, and we can see I've left over here the byte array that it loads, so we can see the 4D5A, that's the MZ header of a PE file. Okay, and the end stage is another simple backdoor, Costura packed and protected, just to thwart analysis a bit. Okay, and also in various after various monitoring, we have also observed some new malware being used that's quite recent. There were some ClearFake attacks targeting France, and they were using a new version of the worm cookie backdoor. We can see over here the images that they were using, so update Edge, Firefox, Java, Chrome, and whatnot, and we can see the main function of the worm cookie backdoor. These are supposed to be some kind of sandbox checks to ensure that it doesn't run on a sandbox. We can see the main function over here with the typical usage of the custom decrypting function and CRC32. Okay, the post back to the C2 server, and also on down below we can see the jump table for the big switch. That's for the commands that it receives from the server and will execute further. And I've also left here the what was new in this version of the worm cookie, because from previous researches and when it was first discovered in summer of 2024, it was documented then, but then no further variants were observed, and we have observed one with these functionalities, more frequent reuses of RC4 encryption keys that they use, and also the entire functionality is listed here. You will see that 7 and 9 are missing. And after the post, we have created some further detections in the error rules for it, and we have managed to actually catch a new file with these options implemented, seeming to complete the list of commands. Okay, so a bit of marketing now, because why not? So how do we protect users against ClearFake in Gen Digital? So you have some stats over here. Since the beginning, we have protected almost 4 million unique users and blocked over 11 million attacks. Of ClearFake, we have covered over 15,000 ClearFake HTML pages and went up the chain for each one to ensure that the entirety of the chain is detected. End stage payloads, middle stagers, contacted IPs, and so on. We have also hunting feeds and so forth, and we also have implemented a clipboard protection feature which scans for these types of attacks and tries to stop them before they even get to do the tiniest bit on the system. And we can see over here by the way, this data is until the beginning of October, and this heat map is the number of attacked users in September this year alone. So we can see they're mostly targeting South America and a bit of Europe and probably India a bit. Okay, and to sum things up, so we have no idea whoever is behind ClearFake. This entire fake update scene is quite a mess since Sogolish started doing this. A lot of players over here started adopting this. ClearFake started using this. Then they moved on from fake updates to ClickFix, which is just another rendition of ClearFake, which is another rendition of fake updates. There are a lot of players in this, so ClearFake, ClickFix, Sogolish, we have fake updates are Smart Tape SG. So it's an entire mess. And nowadays we have seen quite a big rise in this clipboard infections, and observed a new ClickFix campaign, which is called Fake CAPTCHA, and it has the user to pass fake CAPTCHA prompts. We all know that we have struggled sometimes with CAPTCHA, like pick this image or pick an image, pick all the images where you see a fire hydrant and so forth, and there's one tiny spot and you don't know where to get it. But this makes the user think that he can pass faster, because what they do, they just ask the user like, hey, open the run dialog, paste in this command, and you'll be free to go. And that's how they get infected. They typically, they still use the same end stage payloads like Luma, net support, Redline, and so forth. But this is the newest rendition in this entire saga. And that was all from my side. Thank you very much. So, are there any questions?
How does the clipboard protection work, and is it annoying for the user?
Sorry?
How does the clipboard protection feature work, and is it annoying for the user?
Is it, did you ask if it is only for the user?
So you said that you implement a clipboard protection feature to actually check for the malicious code when a user clicks on the copy button, copy to clipboard, right?
Yeah.
And how does it work? Like, does it scan the code that's actually being copied into the clipboard?
It scans the clipboard of the user, and we have some rules for it. Like if we see PowerShell being executed, that's a huge red flag. Like that's sent to us to further analysis, and we have some other rules that it goes through until it ends up being submitted to us. But yeah, that's the gist of it.
And does it have any impact on performance? Like me as a user, if I click on that copy to clipboard and it's actually a useful copy, is it slow? Can I notice it?
I don't think so. I personally use Avast and I haven't had performance issues, but it differs from laptop to laptop. And there were users like saying huge performance issues, but I can play Microsoft Flight Simulator and render something and just be fine with it. So that's a bit subjective, but I haven't personally seen anything, and I'm not, I think, the right guy to ask because I just analyze malware.
Right, thank you.
Thank you as well. We had one over here and one over here. If you could bring the mic, thank you. Over here, and there was a gentleman in the back.
Thank you. Great presentation. So I had more of a curiosity. I think showing a fake CAPTCHA is pretty ingenious, and I was wondering, do threat actors turn to psychologists or something like that in order to decide how to trick people, or do they just use their imagination?
I think the imagination suffices because I mean, you just have to. There's a bit of psychology involved as well, because you have to put yourself in the shoes of the user and see what a normal user would get fooled by. And this is, like I said, the ClearFake stuff. You just navigate to your favorite website, your news outlet, and so forth, and you just see, like, you're used to being on that website, knowing how it looks, and you see a pop-up which seems normal. You're also used to error messages and pop-ups for updates and so forth. And it takes a bit of ingenuity to put it all together, but I think that's all they need. But in this fake update scene, since Agoli started using this, there were a lot of new players, and I think some of that may be psychological, like, as you said, the fake captcha, which is the newest click fix. That's a bit of psychology involved in there as well, because, okay, why would you go there in the first place? Like, but yeah, some will, some not. Some will resort to actual complex exploits like Lazarus, bringing out 0 days like it's nothing, and some will resort to just tricking the users with some elementary psychology.
Thank you.
I think as well.
Thank you for your presentation. I wish to ask you if you studied the possibility to implement, if you discover such a pattern, a solution based on AI agent, because this type of fake is develops and evolve inside the browser. So it could be a best job for an AI agent, which have a lot of speed and a lot of usefulness in this case. Could you consider this?
Yeah, I think that's a really viable option, but just adding another, like, AI scanning the user screen or the entire HTML pages that the user browses on top of the already existing engine and all the monitors and whatnot, this might be a little performance exhaustive, but I think it's a viable option, and we have considered trying to make some detections on that side, but we haven't gone deeper enough into that to see. But it's definitely something that's doable. I think there was one more over there. Yeah.
Thank you for the presentation. Based on your analysis and in your opinion, why there are so many stages in the payload? I presume the main intention of the attacker was to not get detected, but with so many stages, you will most likely be detected at one point.
Yeah, and not necessarily, because you can make you can have like 10 stages and all to be undetected. You can check out there was a blog post on our blogs on Avast by Luigino about some new Lazarus attacks, which they had a very big attack chain, and the entirety of it was undetected because it was new, complex stuff, and so it's not necessarily to be detected. If you use simple stuff like PowerShell droppers and so forth, yes, you might. But it depends on the quality of the payloads. And to answer the first part, it's mostly to try to break the chain somewhere. Like you can have, so when another analyst sees the web page, they might go and get that next stage, but some place somewhere there will be some restriction which they hope it won't allow the analyst to go any further and see what the end payload is and what they are actually trying to do on the system, because without that you might infer that the payload is malicious if it does the stuff I've shown without seeing the actual final payload. But that's just trying to, because if they were to be using custom malware, they wouldn't want it to be in the hands of the analysts, so they can create detections for it and so forth. So my guess is that they're just trying to hide the end stage payload and hope that somewhere the chain breaks and it won't get into the hands of analysts. Thank you.
Yeah.
Okay, thank you everybody.